All right, so today we're going to talk about 3.1, 3.2. It is focused on frequency distribution. So choose the classification. These are the steps that you're going to go through. A, category should not overlap and cover all possible values. So choose the classification. A frequency distribution you have seen before. It is when you go around and you ask a bunch of people football, basketball, or soccer, and you pick one. And which one's your favorite or something like that, and you get tally marks for each one, and it's the frequency or the amount of times it comes up when you ask them. Okay, so when you choose the classifications, categories should not overlap or cover all possibilities. So they shouldn't overlap. So like if we were in England football and soccer, if we were doing all Europe and United States, that could be an overlook because soccer could be talked about as football, so that would be a problem. Another one would be covering all possibilities. If I came through this classroom and had everybody pick a sport and someone says cheerleading, it did not cover that possibility, so I'd have to add cheerleading to that possibility. Okay. B, the qualitative categories are easy to identify. Favorite color, blue, red, green, etc. Okay. So they're very easy, like football, basketball, soccer, pretty fast, pretty easy to pick. Quantitative categories can get messy with some value range. Ranges help with this, okay? So quantitative would be like all people that in wrestling rate from 100 to 109.9, and then the next one maybe 110 to 119.9 is the next weight class. Okay, so I don't know what the weight classes are, but that would be an example, and then we take tallies, seeing how many actually weigh that. Count the number in each classes. That's when we do the tallies. All right, so an example, a small commuter airline in the West keeps records of complaints received from its customers. Complaints are listed in the following table. Find the relative frequency for each category, then answer the question. So relative frequency is how many it came up over how many there were total. So first of all, before we get started, we need to sum this on up to see how many total complaints there were. Now to find the relative frequency, I'm going to take that 26, the frequency that happened to tickets cost too much, over the 165, which is all of those. And I'm going to make this a reference by putting dollar signs, push enter. So 16% of those complaints were tickets cost too much. And then you can come and drag it since we're on Excel, or you could keep going 11 over 165, 29 over 165. Okay. Over here, my questions are how many complaints were made? Well, how many complaints altogether were 165? What percentage of complaints were the temperature of the plane? So we're looking for too hot or too cold. These were the too hot, too cold. So I would need these two together. So I'm going to do equals 16% plus that 8%. And that is 24%. Would these categories be qualitative or quantitative? These are talking about qualities of the plane, not like a number or quantity. So this is going to be qualitative data. What is the level of measurement? All right, so if we're talking about this, does the order of these matter? So we know it's qualitative, so that pushes it down into either nominal or ordinal. Now to pick, does order matter? If order does not matter, it is nominal, which order does not matter, so it is a nominal measurement. All right, now if we're constructing our own frequency distribution, number one, we would determine how many classes we would like. So how many breakups, how many different categories would we like. Determine the class width. You take your maximum value minus your minimum over the number of classes. Round any decimal result to integer to keep classes easy to comprehend. And you're going to want to round up on that. Step 3, find the class limit. So the lower class limit is the smallest number in a class, and then the upper class limit is going to be the largest number in that class. So lower will be the lower, upper will be the top. So like on my previous example, 100 to 109.9, 100 would be my lower, my upper would be 109.9. Determine the frequency of each class, and then how many times does that occur. A data set is containing the heart rates of 50 students is given. Create a frequency distribution in the table below. Then find the relative frequency, cumulative frequency, and cumulative relative frequency. So to start off, let's go ahead and see if we were making our own frequency distribution. So step 1, we need to decide how many class bins we are going to have. So if I was using the same one to see if I can get the same results, so 1, 2, 3, 4, 5 class bins, okay? From there, we need to have the maximum. We need to step 2, which is determine the class width, which is max minus min over number of classes. So maximum of these numbers, so equal max. I need to find all of these maximums. And then I need the minimum, which is equal minimum. Okay, select all of these, enter, and then if I was finding my width, right, I would do parentheses maximum minus minimum over that class bin, how many there are, how many bins. So 7.2, so I'm going to actually count by 8, and what you do is you count your lower limit by 8 to the next lower limit. So 60 to 68, 68 to 76, 76 to 84, 92. So we would have this, and then you would go right underneath that lower class limit. We'll talk more about this next class period. Okay, now to make our number of frequencies. So without counting all that, that's going to be a lot of work. So to not have to count it and to find the frequency, how you do this, okay, what you are going to put in Excel is equal frequency, and then you're going to put the array and then the lower class limits, or the upper class limits, sorry, upper class limits. And then close parentheses. So over here, I'm going to put upper class limits right here. Okay, my upper class limits are 75, 83, 91, 99. So then from there, I'm going to put equal frequency. And I'm going to select the arrays, comma, and then select the count, or the bins array, the top. And then it should fill in, and this should add up to 50. If I tried it, equal sum. And 50 is my total, so that's the total, okay? Now, relative frequency, again, you're going to take that number of students divided by your total number of students, so, and then we're going to fill that on and down, okay? Now, cumulative frequency, that is talking about the cumulative, how many times it comes up. So every number under 67, which is 3, and then every number under 75, which would be 12. So you would take this plus your new number, okay? And then you can do the next one if you would like. So you're going to take the previous number plus that new number that you just added, and instead of keep doing that, we scroll down, and the last number should be 50 because all numbers are below 99. Cumulative relative frequency, so you're going to do the same thing except you're doing that with these numbers. So 6%, and then here I would take that 6% plus that 18%, and that's 24%, and then you can go all the way down, and this should be 100%, so it should be getting higher as you go on both of these. Okay, the sum of the relative frequency in all classes below is the cumulative relative frequency. The cumulative frequency is the sum of the frequencies of the classes, a class in all classes below. So cumulative frequency, think of just the frequency. This is cumulative relative frequency. We're talking about the relative frequency, or the percentage. All right, so now let's talk about bar charts. So this one is laid out a little bit different, but it's talking about, it's still a bar chart. So lack of parental involvement, Lewis Harris poll. This is going to be looking at what we're talking about, is talking about very serious, somewhat serious. So this is going to be a qualitative data set, but over here it says percentage of frequency distribution. So be careful. This is not just talking about the frequency. This is talking about the relative frequency. So how often percent-wise did it come up rather than just the frequency, okay? So there's difference between frequency and relative frequency, and you need to know that difference, okay? These two bar charts right here actually show the same exact thing, or data, but it is shown differently. So in order for a graph to be biased, unbiased, and just to look at it, we like to always start at 0 on our graph and go up, but it's really hard sometimes using that to see where different values are. So what we do is sometimes we zoom it in or we skip numbers, and that's what this one's showing. So they're talking about the same people, same numbers, but in this one was the better graph overall. But when I want to find values in data, sometimes we kind of zoom in or redo the data so we can see the data, and we skip some numbers to 180. So this would be like more like 187 maybe, while on here I would probably have said 175, okay? So that is why two different graphs could be needed or used, but this one would be the one where it needs to have that 0, okay? All right, Pareto chart. I don't know if I said that correctly, but those are bar graphs whose bars are arranged in decreasing order of frequency. So the highest number all the way to the smallest. This can happen when it's talking about qualitative data, where the biggest number goes all the way to the smallest number. That's a Pareto chart. Stacked bar chart, where order down here doesn't matter. Okay, stacked bar charts figures put together. Okay, so they're bar charts. They're just different bar charts all put into one bar chart. So the gold medals are all the gold, the silver medals, the bronze medals. So these could all be our own bar chart, or you can put them all together. According to the graph of Winter Olympics medalists count 2014, what country brought home the most medals overall? So looking at which one is the highest, it would be Russia. Okay, who scored more silver medals, Norway or Canada? So we're just looking at Norway and Canada. If we're just talking about silver medals, Canada would have scored more. But if we were looking at medals altogether, it'd be Norway. So Canada scored more silver medals than Norway. Okay, now we're going to talk about pie chart, a visual representation of the proportion between part to whole. So you've seen these, and it is the whole chart, but we're only talking about parts of the chart. So it's 3.36 trillion is all the money that we spent, but this would be the Social Security money that we spent on that out of that 3.3. This would be the Medicare and health percentage, okay? So how much money did the government spend on national defense according to the pie chart? So using this pie chart, I want a percent. I don't want the full thing. I just want this national defense is the gray, 16%. So what you're going to do is equal, and we're going to do the whole 3.36, and we're going to multiply it by our part, which is 0.16. And I'm going to go ahead and round this to the hundredths place. So this is we're going to round it to 100th place. So it's going to be maybe. Okay, so it's going to be 0.54. And we have to label it, so trillion dollars. Okay. Next one, how much money did the government spend on Social Security according to the pie chart? So Social Security, I'm going to do the same thing. Total amount of money that I spent was 3.36, and I'm going to multiply it by Social Security, which was 0.38. And if I round this to, let's say, the second, and so it would be 1.28 trillion dollars. All right, that is 3.1, 3.2 for you.